I'm building a 2-trailer tiny house, and these are the trailers I made. Both of these trailers are identical, and I've custom built them from the ground up for my tiny house. They're flat deck trailers with a 4.8 metre by 2.4 metre deck, and from tip to tail, these things measure just over 6.5 metres. Each trailer weighs 600 kilos and has a total load rating of 3,200 kilos, which gives me 2,600 kilos per trailer to work with in my build. They're dual axle, sitting on roller rocker springs. Each axle is rated to 1,600 kilos, which gives me my 3,200 kilo load rating. The roller rocker springs are rated 3.5 tonne. Trailers are constructed out of Duragalv steel with all the welds cold galv. I've gone with Duragalv because it's rust resistant and I don't have to worry about coatings. Okay, let's have a look at these things in a little bit more detail. In this video, I'm going to go into what I built. I'm going to do another video on how I built it, so time lapses of build, etc., and I'll link that down below. So first off, the structure. Now, tiny house trailers are significantly different from standard trailers. Standard trailers are designed to take a mass somewhere near the centre of the trailer or spread across the bed and a really low centre of gravity. Tiny house trailers, on the other hand, have a house sitting on them that have terrible aerodynamics. They've got a much higher centre of gravity, and more importantly is how they distribute load to the trailer. So if we get our trusty tiny house mock-up and we lift off our house, which is our main source of weight, and we look at how it transfers load, we can see that the majority of the weight of the house is transferred to the perimeter of the trailer via the external walls. Now that's significant. When we look at our trailer, we can see that our load centers here, which is our spring hangers that distribute weight to the springs and through to the wheels, are situated here, yet we have the majority of our weight being focused down on extremities of the trailer out here. So as I was designing my trailer, there were two things that were really important to me. First of all was to have a really strong perimeter so that I had something solid to bolt my walls down to and make sure this thing's going to be positively fixed to the trailer, can withstand the forces that are going to be applied to it as it travels down the road. Secondly, and even more importantly, was that our undercarriage here that was going to be solid enough to support this house and not get movement. I've achieved that by doing ladder truss rails that run full length of the trailer. Then I have ribs that are full width that cross over the top of my chassis rail and weld directly onto my perimeter. Hopefully that should give me a strong foundation. This thing won't turn into a banana and I won't get movement in my house. Axle offset. That's where the centre of the axles, which forms the fulcrum of the trailer, is moved back from the centre of the trailer. We do that so the centre of mass is forward of the fulcrum, putting down weight in the toe ball of the vehicle, which is critical for stability. There's a popular rule of thumb to shift them back 10% the length of the trailer. However, I've only gone back 5%. I've done that for my houses because on both of my trailers, the front of my trailers are going to be far heavier than the rear of my trailers. There's a common misconception that gets around tiny house forums to put all of the weight at the front of the trailer. That's wrong and it's dangerous. We know about putting too much weight at the rear of the trailer that can create a pendulum effect and cause the trailer and the tow vehicle to fishtail out of control. However, putting too much weight at the front of the trailer can create damage to the tow vehicle or even worse, an accident. Tow vehicles will have a maximum down weight they can take on the tow ball. Exceeding that can damage the vehicle. But more importantly, it can create an accident. With all the weight pushed down on the rear of the tow vehicle, it lifts the front of the tow vehicle, which reduces traction on our steer tyres. So we're coming up to a corner, we say turn, trailer says we're going straight. Doesn't end well for anybody. It's really important that we're working out how we lay out the tiny house or where we're positioning our axles, that we have the centre of mass forward of the fulcrum, putting a down weight on the tow ball, but we don't exceed the capacity of the vehicle. Springs and axles. I didn't design any of this, they're all covered by Australian standards and just have weight ratings. Easiest way to order these was to work with the supplier, and they got calculators that can help work out axle widths. All I had to do was to dictate what weight I wanted to build up to, what the overall width I wanted was, and what the rim offset was. The rim offset was important because it dictates where the edge of the wheel will end up in relation to the hub here. These axles are rated at 1,600 kilos each, which gives two of them gives me my total 3,200 kilo weight rating. They have 10-inch electric brakes all round, which is mandatory on a trailer this size. Also mandatory to have a breakaway controller that will deploy the brakes if it detaches from the tow vehicle. These springs are roller rocker springs rated at 3,500 kilos. They've got rollers in the ends here that allow the springs to move easy as they flex, and this rocker in the middle helps distribute the load between the axles as it traverses terrain. The one thing I did have to design was how I attach my spring hangers to the trailer. The spring hangers are these pieces of steel that attach the springs that support the axles onto the trailer. Now these things are really important for a couple of reasons. First of all, 90% of the load of this trailer is going to be transferred to my wheels via these 6 points. Secondly, these things are subject to some pretty serious longitudinal and lateral forces as this trailer moves down the road. When I got them, these spring hangers were just U-shaped pieces of steel. Had I welded them directly onto the chassis rail as it is, the chassis rail could have failed by buckling, or more likely, these things can crack welds really easily because of the forces that are applied to them. When I was designing how I was going to attach my spring hangers, there was two designs I looked at. The first was to take plate steel, weld it down the side of the chassis rail and onto the front of the hanger. Now I actually think that would have been the stronger of the options. The reason I didn't go with it was A, it meant using a lot of steel, B, it felt like I was putting a lot of heat to the chassis rail. Also, it felt like a bit of overkill. The method I have gone with is to put 10mm plate steel on the base of this hanger and fix it onto the chassis rail. That allows me to get a really good weld between this hanger and the plate, and then stitch weld my plate onto the side of the chassis rail, which distributes the load and makes it much stronger. This rear hanger here doesn't have bracing like the others because this is a roller here and it doesn't have the same twisting forces. Our centre hanger is the same with a 10mm plate steel, but it's got this triangle piece in here that braces this piece because it can get quite a few forces from this rocker rocking back and forth. Front hanger, easily the most important hanger on the trailer. The reason it's so critical is when you're travelling down the road and you've got a 3.5 tonne trailer plus tow vehicle heading in one direction, and this wheel here hits a pothole, all of a sudden wants to head in the opposite direction. What happens is the axle pulls on this spring and this spring pulls on this hanger. Without any bracing here, it gets this massive twisting force applied to it. It can very easy crack welds, or even worse, start to tear the hanger off of the chassis rail. Not a pleasant situation. What I've done to strengthen mine is to weld in a 10mm by 250mm plate steel that extends well past the front of the hanger. I've then braced it in with this angle piece to strengthen it up. What that does is when this spring now pulls on this hanger, that bracing piece helps translate that twisting force into more of a lateral force that's parallel with my welds. The plate helps distribute the force across the chassis rail over a longer distance and also helps distribute the load. If you're ever looking at a tiny house trailer or a trailer in general, the strength of these front hangers is absolute paramount. This is one way of doing it. Another way is, like I mentioned before, with the plate steel down over the chassis rail, or another popular method is to extend the drawbar back into the front of the hanger and weld it on. Drawbar. The design I've gone with here is to stitch weld together two pieces of RHS. I've gone with that because it's stronger than a single piece of RHS the same size. There's two reasons for that. First of all, when this is under load, the bottom of this drawbar is going to be under tension. The piece of RHS on the bottom is stronger than a single wall of RHS. Secondly, and even more importantly, having this join through the centre of the drawbar makes it far stronger than a single walled piece of RHS. The reason for that is when RHS fails, well in this situation anyway, the wall would collapse out and push in, you'd see it buckle. By having this join through the centre here, it makes the wall of this drawbar far stronger. Tow hitch and chains. I've attached the tow hitch by welding in plate steel at the apex of the drawbar. I've welded on both sides, but I've also positioned the hitch so that these front bolts actually purchase into the steel of the drawbar. I have seen these welds fail, and even though I hope my welding's better than that, just in case there's ever any issues, purchasing into the drawbar ensures there won't be a complete failure. The chains, which seem pretty straightforward, even have requirements in a trailer this large. They must comply to Australian standards for the weight rating of the trailer and need to be stamped with the standard every 4th link on the chain. The same goes for the shackles that are used. They must be rated and their braking capacity must far exceed the capacity of the trailer. I've attached the chains by welding in 10mm plate steel to the wall of the drawbar and then drilling through for the shackle. I've done that because as you get up to this size, you're not actually allowed to deform the link of the chain, and that includes welding it. So I've drilled through and put a shackle in, which also I think looks a bit nicer. Finally, while we're going, a couple of extra little features I built on these trailers. Swingway number plates. These flat deck trailers have heaps of room underneath, and I think I might want to try and use them as storage later. And let's not forget the most important part of this tiny house is the ability to join these two trailers together. I've welded a hitch onto the side of this trailer, the second trailer is going to hook onto and join my two trailers together. So that's it. Obviously, there's heaps more to build in these trailers, but there's only so much I can fit into a video. If you do have more questions, put them in the comments below and I'll try and answer if I can. Preempting a question I often get, I won't be making any plans available. I'm not an engineer and I can't be sure that these trailers be safe for everybody. If you are going to build your own trailer, please make sure you have sufficient knowledge and experience to put these things together safely. It's worth noting, I'm not an expert in any of these fields. I'm just sharing my own knowledge and my own experience in the hope that can help someone else on their own journey. Never take anything I say verbatim, always balance against your own research. If you're an actual expert in something I'm talking about and you see something that could be corrected, don't hate, educate, comment down below with something that actually helps inform people. I'll see you again soon.